And guys, in this video, we're learning about how to find the inverse of a function from the graph and the table. So first of all, what is an inverse? An inverse function is one that's going to reverse or undo the original function. And when we're looking at the graphs and the tables, we are literally just going to swap the x and the y. So a lot of students assume that that means change the signs, but it doesn't. You keep the signs whatever they were, you just swap the ordered pair. So not every function has an inverse that is also a function. Sometimes the inverse is just a relation. So on a normal graph, if you remember, we can do the vertical line test to see if the original graph is a function. Since the inverse is the opposite, we need to do a horizontal line test to see if the inverse will be a function. So if the inverse is not a function, we just have to use y equals. But if the inverse is a function, then we have this new symbol where instead of saying y, we have that fancy f of x, only the f has a -1 as the exponent. So if you see that symbol, the only thing it means is that you are looking at the inverse, and the inverse is also a function. So this line is a function, and if I try a horizontal line test, this passes. So this means the inverse will be a function. Whether it's a function or not, we can go ahead and graph it. 0, 5 will become the 0.50. 3, 3 will stay the same because if I swap those, it's still just 3, 3. But 1, 6 will be that new point because I have to swap the 6 and the 1. So I'm just going to plot those 3 points. There's 5, 0. There's 3, 3. There's 1, 6. And so if I draw those, well, pretend I can connect dots. That new line is the inverse of the original line. An easy way to tell is if you graph the line y equals x, the graphs should be symmetric when you flip them over that line. That should be a line of symmetry for your graph. And so I can tell that this is symmetric. To me, it almost looks like dragonfly wings. I don't know, I'm weird. But I can tell that it's symmetric. If I fold the paper over, everything lines up. All right, so these next 4 are just examples of why these 2 graphs, the inverse will be a function. This passes the horizontal line test. So when I go to find the inverse of this, I can use that fancy symbol. Same thing for this one. This passes. A horizontal line is only going through once. So I can use that fancy symbol when I go to write the inverse. But if you look at this graph, see how a horizontal line is going through more than once? So the inverse is not going to be a function, which means I'm just going to have to use y equals when I go to write the equation. Same thing for this. If you see this horizontal line is going through twice, so all that means is I'm not going to be allowed to use that fancy symbol. I'm going to have to use y equals when I go to write my equation. All right. So here's just another example. I'm going to fill out my table of values just using the graph that's here. Now, this will be a function when I take the inverse. If you look, this passes the horizontal line test. So when I go to make the inverse, I will be allowed to use that fancy new notation. All right, so all I'm going to do is just find points that are on here. So I'm not going to necessarily use every single point, But let's do 0, 2, 1, 3, and 2, 5. Let's start with there, because the other ones are not really exact. So make the new table by swapping the x and the y. That's how we're making the inverse. We're just swapping the x and the y. So the 0, 1, 2, that was in my x's. 0, 1, 2 now becomes the y's. 2, 3, 5 becomes the x's. All right, and I'm going to plot those points. So I'm going to plot the point 2, 0, 3, 1, and 5, 2. And if you can see, it's kind of curving like up. So to help me make the graph just a little bit better, you can either estimate what those other points were, or we can draw that y equals x line and just try to make it look symmetric. I probably will try to figure out what this point is. That point looks like -2, -1. It's not perfect, but, or -2, +1. So I'll flop those. So that would just kind of help me make it look a little bit better. So it's not going to be perfect, but that's okay. Pretty close, right? So the inverse is a function. And so I knew that it was going to be a function because my original graph passed the horizontal line test. All right, so now that we have both graphs and we also have both tables, when the question wants you to evaluate, you just have to pay attention to whether it's asking you to use the inverse graph or the original graph. So again, where we had f of x, that's my original graph. My original graph and my original table. So this is asking me to evaluate when x is 5, but using the inverse function. So remember, the number in the parentheses is the x, but this wants me to use the inverse. So if I look on my inverse table where the x is 5, my answer is 2. Over here, this is asking me for f of x. This is the original. So on the original copy, when x is 0, I can see my answer is 2. All right, one thing that they might try to do to throw you off is ask you for this. So this is called a composition. And so a composition, we do what's in the inside first and then work our way out. Now, this is the original copy and the inverse. So this is going to come out to equal 3 because you're just swapping the x's and the y's twice. So you swap them the first time to do the first answer, but then you're just going to swap them again to do the other one. So I'll show you on the table. If I use the inverse copy and I see where x is 3, my y is 1, and then I go to my original copy and see where x is 1, the answer is 3. And so that's going to be the case all the time. Anytime you have this composition where you have both of them, the answer is going to equal whatever that number is in the parenthesis. So I can give you a number that's not even on this table. I can have you do that same notation, but put 200 in here. And it doesn't matter that you don't have a graph, you don't have the equation, you don't have a table. If this was 200, then the answer would be 200. And that's whenever you're doing the original and the inverse in the same problem. All right, you should try to do the next graph. See how far you can get of the next graph by yourself.